All right, so now we have a medic helicopter delivering food in emergency situations. Aren't these fun? So, it's difficult to land. Engineers tasked with determining what heights the package could be dropped without breaking. She knows the package strikes the ground faster than the critical speed of 76 miles per hour. 76 miles per hour. Then the package will break. Neglecting drag. We're going to drop this thing. And V final has to be no greater than, so it has to be less than or equal to 76 miles per hour. So that right there is a mixed unit. And when I say mixed unit, what I mean is we're dealing with miles per hour. And you know that we, in the physics world, are looking at things in terms of gravity. So the acceleration for this dropped object is equal to g. And that's equal to negative 9.81 meters per second squared. Okay? So, since we have meters and seconds here, and we have miles per hour here, I'm going to show you a really cool little trick. If we take either one, let's do meters per second. Let me get a straight line here. And we'll make it kind of lengthy. Close enough. And we'll be back to meters per second. And we'll do a little unit analysis. And we're going to go miles per hour down here is what we want to end up with. So meters on top. And we're going to say 1609 meters is 1 mile. So meters cancels. And seconds is here, so we need seconds on top. So 3,600 seconds is 1 hour. So seconds cancels with seconds. So now we're left with miles per hour. So the conversion here is to take 3,600 divided by 1609, and you get 2.237. So meters per second times 2.237 equals miles per hour. That means miles per hour divided by 2.237 equals meters per second. So the first thing we're going to do is we're going to convert 76 miles per hour into meters per second. So 76 miles per hour divided by 2.237 equals, you see here, 76 divided by 2.237 is 33.97 meters per second. So 33.97 meters per second. Now that is going to be our V final. So when you drop something out of the helicopter, what is V initial? V initial is 0 meters per second. V final is going to be negative 33.97 meters per second. So then our acceleration is g, and our height is the question mark. Okay? So now we've got a couple of scenarios here. We don't know the time it takes for it to fall, so we can't do an average velocity thing. But we do have one of the equations, one of the kinematic equations that says V final squared minus V initial squared equals 2a change in distance. So we're going to call this change in height. So, and our acceleration is g, so 2g change in height. Change in height is what we're looking for. So our change in height is going to be from somewhere up here. So the final is going to, height final is going to be 0. So that means our change in height is going to be negative, right? Starts out positive, ends up at 0. So final 0 minus whatever positive number. 0 minus a positive number is a negative number. So our change in height is going to be negative. G is going to be negative. So these two negatives are products, so the negative sign goes away. So now V final is the 33.97, negative 33.97 squared, and that negative goes away, minus V initial. What is V initial again? Oh yeah, it's 0, so that goes away, equals 2G. Remember, that's negative, and this change in height's negative, so we're going to say 2G is 19.62 times H. So we divide both sides by 19.62 divided by 19.62, and that works out to be 33.97. Negative 33.97 squared is 33.97. Squared is 1153. Let me make sure I got that right. 33.97 squared. Yeah, 1154 divided by 19.62. So that's 58.81. So this turns out to be 1152 divided by 19.62, and that works out to be 58.82. And that's meters, because this is meters squared per second squared. And 19.62 is meters per second squared. So the per second squared goes away, and this meter has 2. So one of those cancels with one of those. So that leaves us with meters. Okay. So our height would be 58. Wow, let me try that 5 again. It looks like I'm a kindergartner writing here. So 58. Not much better. 0.82. So 58.8 meters, and then could package be dropped safely from a height of 50 meters, and the answer is yes. Because at 58 meters, we're good, and if it can be dropped from 50, that's less than 58, so we're good. Remember, that has to be less than or equal to. So the height critical has to be less than or equal to 58.8 meters. So that the velocity it hits with has to be less than or equal to 76 miles per hour. Wow. Okay. That should do that one.